10 time travel science facts you won't believe. What if I told you time travel isn't just science fiction? From wormholes and relativity to black holes, and even real experiments, scientists are already uncovering ways time might actually be bent, stretched, or even reversed. And here's the kicker. Some of these discoveries sound like they belong in a movie, but they're backed by real science. Stick around because number 1 will completely change the way you think about time travel. 10. Time dilation. Proven. Astronauts and atomic clocks. Think time travel is pure science fiction? Think again, it's already happening. Thanks to Einstein's theory of relativity, we know that time flows differently depending on speed and gravity. Astronauts aboard the International Space Station, zipping around Earth at 17,500 miles per hour, actually age slightly slower than people on the ground. Over 6 months, the difference is tiny, fractions of a second, but it's real. And it's not just astronauts. In 1971, physicists Joseph Haffel and Richard Keating carried atomic clocks on jet planes flying around the world. When compared with identical clocks left on Earth, the airborne clocks no longer matched. Depending on their flight direction, they had gained or lost time. These aren't just thought experiments. They're proof that relativity is real, and time itself can stretch or shrink based on motion. Every flight, every orbit nudges us into the future at a slightly different pace. It may not be Hollywood-style time machines, but it means something mind-blowing. We're all time travelers already, even if only by billionths of a second. 9. GPS, everyday proof of time travel. The most ordinary example of time travel is sitting in your pocket right now, your phone's GPS. At first glance, it seems simple. Satellites orbit Earth and tell us where we are. But here's the twist. GPS works only because it constantly corrects for relativity. Satellites 12,500 miles above Earth move at nearly 9,000 miles per hour, which slows their clocks down compared to ours. At the same time, weaker gravity up there makes their clocks tick faster. The result? Their time drifts by 38 microseconds every day compared to Earth. That might sound tiny, but in GPS terms, it's catastrophic. Without adjustments, your location would be off by nearly 7 miles every single day. So engineers had to bake Einstein's equations into the system. In other words, every Uber ride, every food delivery, every Google Maps search relies on relativity corrections. Without Einstein's equations, GPS would collapse, and you'd be lost in more ways than one. That means time travel math isn't just in labs or space stations, it's woven into modern life, proving every single day that time itself bends. 8. Quantum time crystals, matter that defies time. What if I told you scientists have discovered a brand new form of matter that literally ignores time itself? They're called time crystals, and some researchers believe they could revolutionize our understanding of time itself. Ordinary crystals, like diamonds or salt, have atoms arranged in repeating patterns across space. But time crystals? Their structure repeats in time instead. That means they can flip back and forth between states in a perfectly regular rhythm, like a pendulum that swings forever without using any energy. In normal physics, perpetual motion machines are impossible, but time crystals behave as if they've found a loophole. First theorized in 2012 and created in labs just a few years later, time crystals are made by trapping atoms or qubits, the building blocks of quantum computers, and forcing them into this strange repeating cycle. They don't just sit still, they tick endlessly, defying the usual laws of thermodynamics. What does this mean for time travel? If we can harness matter that ignores the normal flow of time, we might one day build systems that manipulate time itself at the quantum level. For now, time crystals are tiny and fragile, but they may be our first step toward machines that bend time on command. 7. Wormholes, the universe's theoretical time portals. If speeding through time sounds incredible, how about stepping through a shortcut in the universe? Enter the mind-bending concept of wormholes, also called Einstein-Rosen bridges. In simple terms, a wormhole is a tunnel that connects two different points in spacetime. Imagine folding a piece of paper so that two distant dots touch. A wormhole would let you jump instantly from one point to the other, skipping everything in between. Now here's where it gets wild. Some physicists believe wormholes might not only connect places, but also times. In theory, traveling through a wormhole could allow you to leap decades into the future, or even the past. That's why wormholes are often called potential time portals, but there's a catch. So far, wormholes remain purely theoretical. Einstein's equations suggest they could exist, but no natural wormhole has ever been detected. Even if one did exist, it might collapse instantly or require exotic matter with negative energy to stay open. Still, the possibility is enough to spark endless debates among scientists and sci-fi fans alike. If wormholes are real and stable, they wouldn't just bend time. They could redefine reality itself. 6. Black holes, where time freezes at the edge of darkness. Few places in the universe twist time as dramatically as a black hole. These cosmic monsters are formed when massive stars collapse under their own gravity, creating regions where the pull is so strong that nothing, not even light, can escape. But black holes don't just warp space, they also warp time. According to Einstein's theory of relativity, the closer you get to a black hole's event horizon, the invisible boundary of no return, the more extreme the time effects become. For the person falling toward the black hole, time seems to flow normally. But to a distant observer watching from far away, something strange happens. It looks like the falling person is moving slower and slower, as if time itself is freezing near the event horizon. In fact, from the outside perspective, they never actually cross the horizon. They appear stuck in time, suspended forever on the edge of darkness. This isn't science fiction. It's a real prediction of relativity, backed by observations of how light and radiation behave near black holes. In short, black holes don't just swallow stars, they swallow time itself. 5. Muons, subatomic particles already traveling through time. When we talk about time travel, it often sounds like pure fantasy. But in the world of subatomic particles, it's already happening. The best proof comes from tiny particles called muons, which are created when cosmic rays collide with Earth's atmosphere or inside powerful particle accelerators. Here's the strange part. Muons are unstable and usually decay in just 2/millionths of a second. By that logic, most muons formed in Earth's upper atmosphere should vanish long before they reach the ground. Yet scientists detect them here on Earth all the time. How is that possible? The answer is time dilation. Because muons travel at speeds close to the speed of light, time for them flows much more slowly than it does for us. From our perspective, their lifespan is stretched, allowing them to survive the journey to the surface. In a sense, these particles are literally living longer by traveling through time. Particle accelerators like CERN's Large Hadron Collider have confirmed this effect countless times, showing that high-speed particles routinely cheat time. It may only be fractions of a second, but it's solid proof. The building blocks of matter themselves are already time travelers. If particles can cheat time, what's stopping us from doing the same? 4. Time travel to the future. Physics says it's real. Forget sci-fi machines and glowing portals. According to physics, time travel to the future is not only possible, it's already been proven. And the best part? You don't need a DeLorean. All you need is speed and gravity. Einstein's relativity tells us that time doesn't tick the same for everyone. The faster you move or the closer you are to intense gravity, the slower your personal clock runs compared to someone else's. That means if you were able to travel close to the speed of light in a spaceship, you could leave Earth, zip around space, and come back to find that years, or even centuries, had passed for everyone else, while you only aged a few months. This isn't just theory. Astronauts on the International Space Station, moving at incredible speeds and living in weaker gravity, already experience this effect. They technically jump a fraction of a second into the future compared to us. So while we may not yet be able to hop back into the past, physics tells us that moving forward in time is not only real, it's happening right now. The future is waiting. We just need to catch up. 3. Loopholes to the past, the paradoxes of time travel. If moving into the future is possible, what about going backward in time? Physicists have debated this for decades, and surprisingly, relativity does leave a small loophole. The theory allows for something called closed time-like curves, paths through space-time that could, in theory, loop back on themselves, bringing a traveler to an earlier point in history. Think of it like tracing a circle on paper. Eventually, you end up back where you started. But here's the catch. Backward time travel comes with some serious problems. The most famous is the grandfather paradox. Imagine you went back in time and prevented your own grandfather from meeting your grandmother. That would mean you were never born. But if you were never born, how could you have traveled back in time in the first place? The logic ties itself in impossible knots. Some scientists suggest the universe might avoid these paradoxes by preventing changes to the past, no matter what you try. Others propose alternate timelines, where changing history simply creates a new reality. So, while equations hint that traveling into the past might not be impossible, the paradoxes raise a chilling question. Would the universe even allow it? Number 2. Quantum messages, information that breaks time's rules. When it comes to bending time, no field is stranger than quantum physics. One of its weirdest phenomena is quantum entanglement, when two particles become mysteriously linked no matter how far apart they are. Change the state of one, and the other reacts instantly, even if it's light years away. Einstein himself called it spooky action at a distance. Here's where it gets mind-blowing. These effects seem to happen faster than light, which challenges our very understanding of time and causality. In some interpretations, entangled particles behave as if information is traveling backward in time or skipping across space without delay. Now, scientists haven't literally sent full messages into the past yet, but quantum experiments have shown that entanglement can make particles respond as if they're communicating outside the normal flow of time. To us, it looks like the future and the past are strangely connected. If this phenomenon can one day be controlled, it could open the door to quantum communication that defies traditional limits. While we're not exchanging text messages with the past just yet, these experiments suggest that time might be more flexible and far stranger than we ever imagined. Number 1, time may not exist, the biggest twist in physics. Here's the ultimate twist. What if time itself is just an illusion and doesn't exist at all? Some of the world's leading physicists argue that time may not be a fundamental feature of reality at all, but rather an illusion created by our perception. At the quantum level, the realm of the tiniest particles, the equations that describe the universe don't always include time as a basic ingredient. Instead, time may actually be something that emerges from deeper processes we don't yet fully understand. In other words, what we call past, present, and future might just be ways our brains make sense of a far more complex, timeless reality. This idea flips everything we know on its head. If time is not fundamental, then traveling through it might not require machines, wormholes, or spaceships. Instead, it could be about changing how we perceive and experience reality itself. Imagine if time travel wasn't about stepping into a device, but about unlocking new ways of consciousness. It's a mind-bending possibility. Maybe we've been trapped in the illusion of time all along. And if that's true, the biggest breakthrough in time travel won't come from physics, but from understanding reality itself. If time is an illusion, then the greatest time travel machine might be our own minds. From astronauts aging slower in orbit, to black holes that freeze time at their edges, to quantum particles already breaking the rules of reality. One thing is crystal clear: time travel isn't just fantasy. It's real science, happening all around us in ways that are far stranger than Hollywood could dream up. We're only scratching the surface. If wormholes can exist, if time crystals can be stabilized, if quantum communication bends causality, then we may be standing at the doorway of technologies that will completely rewrite what we know about past, present, and future. So let me throw it to you. If you had the chance, would you risk the paradoxes of going back, changing history, maybe even erasing yourself? Or would you leap forward, skipping decades or centuries, to witness the future of humanity? Drop your answer in the comments. I'm dying to know which side you're on. And if your brain feels scrambled after this countdown, do one thing before time slips away. Hit that like button, subscribe, and ring the bell. Because next time, we're diving into mysteries that could bend reality even harder. Trust me, you don't want to miss it.